is relentless. As we solve yesterday's issues, we are faced with pressing, greater and harder problems. As we kiss goodbye to diseases such as polio and tuberculosis, cancer has become the leading cause of death in New Zealand. As our nation continues to build its economy on the agricultural sector, harmful viruses threaten to annihilate this. As our energy consumption soars, global warming is keeping apace. Fortunately, we have the power to combat these issues. We can literally build a brighter future if we harness the power of bioluminescence. So, what is bioluminescence? This is basically when living creatures produce their own light through chemical reactions. We've all experienced this phenomena. The glowworms at Waitomo Caves are an example of this. However, it is most common amongst deep water sea creatures such as jellyfish and the anglerfish. In their light-producing organs, a molecule, luciferin, combines with oxygen, and this reaction is sped up through the enzyme catalyst luciferase. The end product is light. However, in some organisms, photoproteins or light-producing proteins are used. So these are like 2-minute noodle packets with all the necessary chemicals pre-packaged and ready to be used as soon as the organism needs to produce light. The most well-known example of a photoprotein is GFP, or green fluorescent protein. This was discovered off the west coast, California, in a jellyfish. GFP has opened up a world of possibilities, influencing the medical and agricultural sectors, and can also be used in lighting. Bioluminescence is invaluable in medical research. Cancer is a life-threatening disease that has resulted in the death of over 8,000 New Zealanders in 2012 alone. Alzheimer's disease is one of New Zealand's growing healthcare problems, with over 53,000 New Zealanders diagnosed. With such horrific diseases tearing apart the lives of New Zealanders, it is important that we invest in bioluminescent research techniques. So you might be wondering, how are glowing proteins related to cancer and Alzheimer's? Well, allow me to enlighten you. Think of GFP, or green fluorescent protein, as a tracking device in a cell. As the cell goes about its business, replicates, or behaves abnormally, scientists can easily track these changes as GFP releases light. So scientists can understand the progression of diseases on a cellular level. It's simple. The more we know about our enemy, the more likely we are to defeat it. Bioluminescence can help illuminate our dark corners, helping us find cures for those suffering from such diseases. But wait, there's more. Bioluminescence can also help our economy, as it preserves our agricultural sector. The agricultural sector contributes to 2/3 of our GDP, so it's important that we are producing premium products. As bizarre as this may sound, bioluminescent proteins can help ensure this. Certain control plants engineered with photoproteins can be made to produce light as soon as the conditions are not optimum. For example, when there's a nutrient shortage, a water shortage, or some nasty virus has invaded the field. This could have helped prevent the destruction of kiwi fruit fields in 2010 by the PSA virus, as you can see here. This cost the industry $900 million, not to mention we were deprived of our scrumptious kiwi fruit. So it is important that in the future we avoid such incidents by investing in bioluminescent technology. So, I've told you about the wonderful ways in which bioluminescence can be used, but there is one extremely innovative yet obvious use: lighting. These beautiful trees engineered with bioluminescent proteins could start to replace traditional streetlights. Our current streetlights contribute greatly to carbon emissions, not to mention they cost $13 million a year to maintain. If we use bioluminescent trees, we can help foster a more sustainable New Zealand. Trees do not contribute to carbon emissions. They can lower urban air temperatures, and they are relatively inexpensive to use. Bioluminescent trees are also 90% efficient. Moreover, we can plant these trees alongside rural roads where street lighting is virtually non-existent. Lumus maximus, and now our motorists can safely maneuver the sharp turns accompanying our nation. San Francisco-based entrepreneur Anthony Evans has already started designing these trees, so streetlight trees are a very real possibility. Bioluminescence is an evolutionary gift, one that can help us transition into the future. It presents us with a myriad of opportunities that are only waiting to be seized. Whether it be in the medical sector, agricultural sector, or in lighting, bioluminescence is the way forward. As I said before, the world is relentless, constantly bombarding us with problems. However, there is hope. There is light at the end of the tunnel. Light in the form of bioluminescence. Thank you.